This is Gaurav Deshpande. I'm the Vice President of Marketing at TigerGraph. And nearly 1,000 people are here online live with us. And I'm sure more people will listen to this when you listen to the recording. So let me first of all say good morning, good afternoon, and good evening, depending on the time of the day that is in your local place. It's wonderful to join you at Data Science Connect. This is my third time presenting to the Data Science Connect audience, and I'm excited every time. Our topic today is talking about smarter AI with analytical graph databases. What I want to present to you really is customer case studies and best practices on how to do this right. So this is not going to focus a lot on product side. I will mention some of the highlights on TigerGraph as a product, but my objective here is really to educate you, those of you who are looking at analytics and AI projects, on what graph databases can provide for you in terms of accelerating your analytics and AI. And then I have an invite for you for a conference in October that we do on this topic, where you can learn a lot more. So some of the case studies that I'll cover today, they'll be presenting live at that conference. So I would love everybody who is listening to right now to attend Graph Plus AI Summit. I'll talk about that at the very end of the presentation. A little bit about me in terms of a context. I have been in enterprise software and AI and analytics specifically for the last 25 years. I have led two startups through explosive growth, I2 Technology that did an IPO and then went on to have a huge market capitalization during the 99-2000 run-up of the market. And Trigo Technologies, which was the largest master data management or MDM acquisition by IBM. That's how I became to be part of IBM for several years, where I built out their big data and analytics portfolio and then married that up with the Watson portfolio, which is their AI portfolio. I have several patents in supply chain management and big data analytics. My passion for last 13 years or so has been the graph marketplace. And what I mean by that is the graph database and analytics and AI that's possible with the graph database. So I'll explain to you, those of you who may be new to a graph database, what it is. I'll differentiate that, how it is different from relational databases or NoSQL databases. I would love for you to connect up with me on LinkedIn if you would like to. And I've also included my email there. My email is really simple. My first name, Gaurav, Gaurav, @tigergraph.com. So I love to hear from people. I love to hear from fellow data analytics and AI professionals, regardless of whether you're on the marketing or commercial side, sales side, or you're on the development side. My background, originally, I'm a developer. I wrote I2 Technologies demand fulfillment product that's part of their supply chain planner. About 1/3 of that product is a part of my initial job at I2. So I come from the development side of the house, and I love to tell customer stories in context of what they can do based on a particular technology. In this case, I'm going to today talk about graph databases with you. So with that little bit of introduction, we'll talk about who is TigerGraph, right? What is a graph database? Why combine a graph database with analytics and AI, and what advantages it can provide? And then those of you who might be familiar with AI, I will go provide you 3 different use cases. Even if you are completely new to AI, don't worry. I'm going to walk you through 3 different ways of how graph databases can accelerate your AI projects. So I'll focus a lot on AI today, but if you have questions about other areas, feel free to reach out. First of all, let's take a step back and understand, why are we talking about a different kind of database? So let's look at the evolution of relational databases. It started with the relational database back in 1970s, where everything, and this is the most prevalent database used in production right now. Oracle is a great example. IBM's DB2 is a great example. Postgres is a great example. Microsoft SQL Server is a great example. All of these store each of these entities, product data, customer data, order data, supplier data, location data, as separate tables. And then in order to do analysis of relationships across these, the blue lines that you see here are called the table joins. And table joins are required in relational databases because every entity is essentially an island of table, and each island or table has to be connected with another island or table to get analysis done. And that's why they are great for transactions, but they are really poorly suited for doing deep analysis of information to find the patterns. And then they are ill suited for doing machine learning, because in machine learning you're taking the analytical patterns and learning from them. So for both of those purposes, relational database are not a great choice for either analytics, AI, or machine learning. NoSQL database that you see in the middle here are key value databases. What I mean by that is they store the information as a simple structure of, there's a key, like a product ID, and then there's a value associated with it. And that basically means that entire table structure, it allows for enormous flexibility. There is no schema. Every row within your table can have a different schema, or different structures, or different set of fields for each object. And then you can vary schema as much as you like. So this became popular, especially as the website e-commerce data exploded in terms of different types of fields required on product information, customer information, supplier information. And then databases like MongoDB that came into to provide enormous value for people to provide flexibility in schema. And they are wonderful for providing highly fluid or no schema type databases, because every row can be a separate schema or a different schema. They are great for high performance for simple transactions, but they are very poorly suited for either analytics or AI, because again, when you're trying to do analysis of relationships, you're going from product to customer, from customer to order, order to supplier, supplier to location. You're essentially traversing the same large table, which might have millions of rows for a smaller data set, or hundreds of billions of rows for a larger data set. And that becomes data analysis, makes it very slow. Graph databases are the third category that came up in 2000s. And this is where the objective was to say, why can't we store the entities as business objects? And why don't we have the relationships, that is, which order is paid with what payment, as directly linked? So the main difference between the relational database, which has islands of information, or key value database, which has a single table with a lot of rows, graph databases don't store information as tables and rows and columns. It stores it as business objects like order, customer, payment, and then it remembers the relationships. It stores the relationships also. So relationships are not second class element. They are first class, and they are very much pre-connected. They are pre-connecting the entities. That makes all the difference, because when you're trying to do data analysis, you are trying to say, tell me which orders resulted in most amount of payments that are coming from a set of suppliers that have provided me with the best products. That kind of a question is very hard to answer as you're going across in a relational database across multiple tables and doing joins. It's very hard to answer here with NoSQL databases, but with graph, it's simply walking the connected data. So whenever you hear the word graph, don't think about graphs, that bar charts or pie charts that you saw. Think, when you hear the word graph, replace that with network of connected data, and then that would be very easy to understand. So when you're talking about this graph database, you're essentially going across the network of business objects and understanding that for analysis and AI. And that's why graph databases are better suited for analytics and AI projects. I'll share some of the statistics in a moment as to how much acceleration and improvement in accuracy can happen with the graph database, specifically TigerGraph. So how important is this trend? Because as data analytics and AI professional, you're constantly getting bombarded with people saying, pay attention to me, my tech is the coolest. Well, I'm not going to say my tech is the coolest. I'm just going to defer to Gartner, which basically said that currently 10% of the people are using graph databases. It'll go to 80% in the next 4 years. That's a very aggressive forecast, and we are seeing this happen in real time as a part of our business at TigerGraph, where we see Fortune 500 rapidly adopting graph databases and scaling those up for analytics and AI. With that introduction, then, who is TigerGraph? We are a graph database, but first and foremost, we provide advanced analytics and machine learning on connected data. Remember, I talked about graph being connected data. So that graph database is the core part, and then we provide advanced analytics and machine learning, and I'll provide you several examples of that today. We are a leader in Forrester Wave report. If you go to TigerGraph.com, you can easily find the Forrester Wave report there, where we are rated as the leader in 9 categories, 9 key categories for enterprise graph databases. We were also named Cool Vendor by Gartner in 2020. It's always nice to be recognized. We are foundational for AI machine learning solutions at our customers. We are designed for concurrent OLTP, online transactional processing, or OLAP, online analytical processing workloads. What do I mean by that? That means a single instance of TigerGraph will allow you to do transactions and analytical processing at the same time. We are built with SQL-like programming language, GSQL, and now we are working closely on an ISO initiative for query languages, for creating a standardized query language for graph databases, and that's called GQL, or Graph Query Language. So we're working closely with them to shape that standard along with Oracle, Neo4j, and other players in the graph market, and we are actively working on shaping that to make sure that our customers are able to benefit from it. Available both for on-premise deployment as well as GCP, Azure, and AWS, all 3 major clouds. Some of our customers I'll review in just a moment. We have the who's who of Fortune 500 companies using us, and there's a little corporate video linked at the bottom there if you would like to take a peek at it. With that kind of thing, I told you 3 things that we do. We do advanced analytics and machine learning, and we do it on connected data. Let me explain that with a step-by-step with components of the platform and what each of the component does. So first and foremost, we are built at core on distributed graph database. What is that good for? It's good for connecting all data sets and pipelines. So here, I'm going to take a customer example, and you'll help you understand why this is a big problem. So one of our customers is UnitedHealth Group. UnitedHealth Group is one of the largest healthcare providers in the world. They provide healthcare insurance, about $243 billion in annual revenue last year. They have 50 million customers or patients. They call them members, 50 million customers or 50 million members that are part of UnitedHealth Group's insurance plans. They wanted to build a customer 360. And when they came to this tiny company at that time, we were 30 or 40 people company. I asked them that question, don't you have this customer 360 with your data warehouse, with your data mart? Don't you have a data lake? And they said, we have all of that. We have data warehouses, we have data marts, we have data lake with petabytes of information. What we are looking for is not just a stale customer 60. We want it off of real-time data. So they have 40 Kafka-based pipelines that have streaming data, things like payments from customers, things like claims from customers, different types of claims, doctor claims, pharmacy claims, physiotherapy claims. All of those are streaming the 40 pipelines of Kafka, Apache Kafka-based pipelines are streaming that data in. They want to marry that up with all of the static data that they have at customer that doesn't change very often, and then produce that into a single customer 360 view for all of their call center agents. So I asked them, what are they doing right now? They said they have 15 different screens that they are switching across to find customer information and answer customer questions. So the first priority is to provide them with a real-time 360-degree view of the customer in a single UI. So if you go to tigergraph.com and go to customers, you will see that keynote from UnitedHealth Group where they show the UI. I'm also going to briefly cover it here in the next few charts. The next customer then, and then what they're doing after they build the customer 360 at UnitedHealth Group is to say my data scientist, when they see a particular bad pattern, such as a particular set of pattern with the customer is resulting in a bad outcome, like somebody who went through a knee surgery, they missed their physiotherapy appointments, and therefore they are now going through a resurgery of the knee. When I found a pattern like that, I want to be able to reach out and see which of my customers are going through a similar pattern and intervene early on so that I can correct that. And I can make sure that customer doesn't have to go through the pain and suffering of going through a resurgery. So those are the kind of 2 things that they're doing, a 360-degree view of the customer and then finding similar patients based on a complex AI pattern, based on 200 features to find real time customers who are going through that journey. Both of those things were not possible with all of their technology investments before TigerGraph came into the picture. Second customer that you see here is a large Fortune 50 retailer. We have built an item 360 for their e-commerce, and this is across 100 different data sets. You're starting to see a common theme here. Whenever people want to build a real-time 360 across a large number of diverse data sets and pipelines, they are using Graph Database to connect all data sets and pipelines in real time. The third example here is a division of AT&T called Xandr. Xandr has built an identity graph for millions of customers across, in their case, they have Apache Spark pipelines. They have about 50 different Apache Spark pipelines that have integrated into a single identity graph. Identity graph is a fancy way of saying I have customers who have multiple accounts, link those all together so I can see the customer information as a single entity as opposed to distributed across the different fragments of the customer history distributed across multiple accounts. So bring it together with a single identity graph. It's also called identity resolution sometimes. So build that identity, do that entity or identity resolution and build that graph for me for across 50 different Apache Spark based pipelines. Next, after you connect the data, what do you do with the data? You analyze that data. So this is where we are 10 to 100 times faster than any of your current solutions. And I would ask you to take that challenge to look at your slowest workload, the workload that's giving you the most trouble, and help bring that, accelerate that 10 to 100 times with TigerGraph immediately. So example here of a customer is Jaguar Land Rover. It's an automotive manufacturer. I'm sure you have seen the cars or used the cars yourself. They used to do supply chain planning with their relational database system, and it used to take them 3 weeks to do the supply chain planning. With the help of moving that supply chain planning, which is a complex table join across 23 different tables, things like supplier data, parts data, orders that are coming in for different vehicle configurations, options like heated seats, like sunroof, moonroof. All of the data is in 23 different tables, and you're trying to do joins across those. Complex joins require a long time. So it used to take them 3 weeks to go through that supply chain planning. Now it's down to 45 minutes. The huge advantage for that was twofold. As they went through COVID-19 pandemic, they were able to react very quickly to supply changes because factories were shut down in different parts of Europe and around the world. And they were able to figure out as the demand itself changed. For example, their demand for Evoque SUV model in United States started spiking in COVID-19 pandemic, and the demand for Discovery started going down. They figured out in a matter of minutes how to take parts for Discovery and repurpose those for Evoque, building the more Evoque models. So what was the end results of doing this acceleration from 3 weeks to 45 minutes? It increased their agility of supply chain planning and responsiveness. The net result was they added 100 million pounds, that's about 140 million US dollars, to the incremental annual profits for Jaguar Land Rover. That's documented. I'm inviting them. They presented at Graph Plus AI Summit in spring, in April, and I'm inviting them back on the fall to share their story. So if you join us in the October Graph Plus AI Summit, I have information for this at the end. You will hear more about it. They also cut their supplier risk by 35%. So that provided enormous strategic advantage in addition to the 100 million pounds in incremental profits for Jaguar Land Rover. China Mobile, in a different side of the world, has about 963 million subscribers. They are the largest mobile service provider in the world. They moved their fraud detection from batch to real time for about 750 million calls per day. And that has resulted in millions of dollars in savings for them, and also helping them preserve their brand identity and improve their customer satisfaction. The last thing that I want to talk about here is in-database machine learning. So remember I said I'll talk about three things. One is a distributed graph database. That's the core of TigerGraph, and where we connect all data sets and pipelines across, examples with UnitedHealth Group, a large retailer, and AT&T's Xandr advertising technology or ad tech unit. Then after you've connected all data sets and pipelines, you analyze the connected data with advanced analytics. And that's where I talked about Jaguar, Land Rover, and China Mobile as examples of different use cases, supply chain planning here and fraud detection here. The third use case, third area of TigerGraph is learning from the connected data with in-database machine learning. This is where Intuit, a fintech that has about $6 billion in revenue, if you're in the United States, I'm pretty sure you have used TurboTax or have seen other people use TurboTax for filing taxes. And I'm sure if you are a small or mid-sized business, you have used QuickBooks, which is their payment clearance service that is used for invoicing and payment clearance. Intuit has built an AI-based customer 360 for entity resolution, for recommendation engine, and for fraud detection. They have cut their fraud in half with TigerGraph. I'll say it again. They have cut their fraud in half with TigerGraph. They will be presenting at Graph Plus AI Summit in October. So be sure to join that in October 12th. Not just Intuit, multiple fintechs and 7 out of top 10 largest bank in the world use graph and machine learning, TigerGraph and machine learning specifically for real-time fraud detection and credit risk assessment. Over 1 billion consumers are protected every day by TigerGraph around the world, around the globe, in United States, in Europe, in Asia, and around the world. So why Graph Plus AI, right? The Graph Plus AI is important because it provides you richer, smarter data. You have connections within the data that those connections are represented as first-class entities that allows you to have better and smarter answers. You can ask smarter questions of the data, which means you can look for patterns that you were not able to find because your data in relational database was not pre-connected. Now it's pre-connected, you can ask better questions. Graph algorithms provide ability to do things like community detection, which is used in fraud detection, it's used in money laundering, it's used in cybersecurity, threat prevention, where you're trying to understand how different entities are connected together and they are acting in unison with each other to do things that they are not supposed to. They are perpetrating fraud, they are perpetrating money laundering, they are attacking your infrastructure for cybersecurity. All of that stuff is possible with Graph. This is very hard to do in real time with relational databases. Explainable results, which is where when you come up with an answer to say this particular customer's credit application has declined, this particular customer is likely to buy this particular product, you can explain that with explainable results, and that's why explainable AI is possible with Graph Plus AI. Graph databases, I explained that they connect objects and they understand relationships better. But I think it's a better thing for me to let an industry expert who has deployed graph and machine learning at JP Morgan Chase. Brad Spires is the executive director at JP Morgan Chase. He defines simply as graphs clarify relationships. That means they allow you to understand patterns in your relationships, connect the data, and then essentially feed that into your machine learning as inputs to make a better understanding of the data. So I love this quote, which is you can turn a hairball of a data and connections on the left-hand side and do it into a more nuanced insight, like finding hotspots within your data of where there's likely to be fraud, where there's likely to be high risk of supply chain defaults, where there's likely to be customers who are actually ready to buy, the positive patterns, and you can find all of those. So this is something that I would explore, and this was presented as a part of the spring keynote by Brad Spires. I'll invite all of you to visit graphaisummit.com to actually learn more about it. I have a few examples here in the following charts. I'll cover those case studies briefly. UnitedHealth Group, we talked a little bit about it, where they wanted to build a 360-degree view of for 50 million customers. Jaguar Land Rover, we talked about it, where they took from 3 weeks to 45 minutes and saved over 100 million pounds every year. And the last one that I'll talk about is Intuit's example of cutting the fraud in half with Graph. First type of things that Graph can do for you as an analytics and AI professional is that it can provide you with analytical queries and graph algorithms. So what are graph algorithms? By the way, you're using a graph algorithm every day without realizing it. Every time you hit enter on the Google to say find something, let's say you type in TigerGraph and you hit enter, the web pages that are coming back are ranked with an algorithm called PageRank. That is a graph algorithm. And that's a type of graph algorithm which is called a centrality algorithm. Every time you get a recommendation on LinkedIn, for example, you connect up with me and you get another recommendation from somebody which says you should probably connect with this person also. That is community detection, and that's also done with graph. Similarity matching is also used actively in social media and in all other ways to say this particular customer has bought from me before. Who are other customers who are likely to buy this product? That's what similarity is used for. Similarity can also be used to say, I have seen cyber attacks from this particular part of internet and these set of machines or these set of IP addresses. Who is likely to attack? Who is behaving in a similar manner so that I can stop that cyber threat or cyber attack? All of this stuff basically allows you to identify patterns. So let's take an example of the healthcare pattern where you're trying to understand these are all doctors, and then there are patient claims that are attached to these doctors, and then of course patients are attached to those claims. Question to understand is who is the most influential provider in each region for a particular medical condition, like treating a particular type of cancer or treating diabetes or hypertension. The reason why you care about it is because as a healthcare provider, when you have new guidelines around diabetes, about particular type of cancer or about hypertension, you want to reach out to the hubs first, the most influential people first, and then reach out to all other doctors because it works well in terms of education. As a pharmaceutical company, you can find the most influential doctors, target them, and those essentially will help you take your drug to market, your new cancer drug, your new diabetes drug, your new hypertension drug. You target the most influential people first. So that's what you want to find out. You can use PageRank basically to find the most influential person. In this case, it's Dr. Thomas. Now, after you have done that, who are the community that's influenced by these leaders? And that's basically community detection. So that's how you detect community connected around a particular influential person. And this is a classic graph algorithm that's used everywhere, and you can use it yourself to do things at your company. Here is what a simplified view of a customer 360. So I remember 23,000 call center agents at UnitedHealth Group look at customer 360 for each of their 50 million patients as they call in. Let me explain how this view is structured. You can see here there are different swim lanes. So enrollment is a swim lane which indicates Doris Smith, this 79-year-old lady, when did she enroll for the healthcare plan with United Health Group? Wellness check, which means when did she have a last wellness check? She looks like she had one in early June timeframe. She had one in early July timeframe, and then she missed one in late August. Prescriber claims, right? What are the doctor claims when she visits a doctor? And those are also laid out in a timeline here. Testing and procedure claims. When did she have medical tests and procedures? Those are laid out. Pharmacy claims are laid out, right? All of this information are separate Kafka pipelines, multiple of those that are all laid out on a single screen, and then married up with all of the static data that you see up here to build the customer 360. Healthcare advisor visits. You can see here that she visited a physiotherapist here, and then she missed 2 appointments along with a wellness check here. Now, this triangle is what led to her having what happened in case of Doris is she had a procedure here. You can see a procedure here for her knee surgery. She was supposed to attend physiotherapy visits, and she attended part of these because you can see she attended these ones, but she missed these first two, and then she missed the wellness check in between. And that has led to Doris having a resurgery. When you find a pattern like this, you want to click here on find similar members, and it used to take them hours to find similar members with their previous solution. And mind you, this is an organization that spends a lot of money on top-notch technology solutions. They have everything. Now with TigerGraph combined with AI, they are able to do it in 50 milliseconds. So in 50 milliseconds, you can find the top 100 patients that are going through this triangle of resurgery and then prevent them from going through that by taking proactive actions. This is what we mean by better customer service, better customer care with Graph plus AI. Graph-based structural similarity or cosine similarity. I'm getting a little technical here, so I'm going to cover it at a very high level. What you're trying to do there is essentially understand what are the commonalities between two people like person A and person B. So let's say Doris and another person, another patient, and you're trying to find commonalities between those. And based on the commonalities, you calculate a score, and that's how cosine similarity works. There is Jaguar and a host of other types of similarity available, but Cosine is quite popular for finding similar patients. Second case that I want to talk about in terms of Graph plus AI, and this is related to financial services now, is related to fraud detection. So traditionally, when you're trying to do a fraud detection, like you're taking an account, you're looking at emails, phone numbers, and other information associated with that account, and trying to find whether it's linked to the fraud here, or like whether it's linked to a phone number, whether it's linked to an email, whether it links to an other accounts that are linked to the fraud. You're trying to do what is called a level analysis or a link analysis. Whenever you see the word hop, it basically means a connection from one thing to other. So when you see 6 hops, I mean go from an account to phone number, phone number to another account to the email, and so on and so forth, to understand the connection, whether this is connected to a confirmed fraud. So this is something presentation based off directly Intuit, the fintech that I mentioned, that's using graph and machine learning to cut the fraud in half. They talked about traditional features that are used for AI, things like aggregation features, like you count the number of payments from a same device in 30 days. Ratio-based features that are number of fraudulent payments, uh, the ratio of number of fraudulent payment to number of legitimate payments for a given device, right? And then raw features like geolocation mismatch, where you see this particular IP address and this particular zip code that's there in the record don't match, right? The IP address is from a different country and the zip code is from a different state, different country. These kind of features are traditionally what is used for traditional fraud detection. They fail miserably because these kind of link analysis is not present. And then graph-based features are all about bringing these link analysis into the equation to find the fraudulent behavior. So I'm going to take that a little bit further to say, as you're looking at this, you're going from account to email to different other entities that are linked here, account to phone number to email and all of the other entities. As you're traversing these connections or hops, you can find a path to a previously confirmed fraud. That means eventually this particular account is connected to a device that has been used in the fraud before in 6 hops or less. Then it's very likely that this particular account will be involved in fraud in the future. And that's how you find the fraudulent patterns. So I can't really discuss details of this because it's proprietary Intuit on how they do it, but we are happy to design a solution for you for your use case that would do similar analysis for you and help you bring down the fraud in your organization. The graph-based feature extraction is the one that we're talking about. You can design different types of features here as a part of the graph. So you can do things like minimum link distance. That means what is the minimum distance between this and another and the fraudulent event. Average link distance, that means if you consider all the links from an account all the way to fraud, what are the different what is the average link distance. Number of links to target, that means I want to limit to only 4 links, I want to limit to 5 links, I want to limit to 6 links or hops. The strength of the link, that means how relevant it is, this particular connection, and then path to target. You can do this complex analysis, and the result is what is interesting. The architecture here, I'm going to briefly cover their architecture. They have the data injection, and they have again Kafka pipelines. You'll see that we are integrated a lot with Kafka and Spark. Kafka for streaming data and Spark for batch data. um, TigerGraph processes and find these links. Those links are then presented in a case management tool. And then we have a UI called Graph Studio, which actually allows the data scientists to explore those connections, those patterns that we have uncovered, and then decide that those patterns need to be incorporated as standard rules. And then that makes the machine learning stronger, that makes the rule-based detection stronger also. So we feed both of those things at Intuit. What is the net results of this? Net result is what you're worried about as a data scientist, as a professional, as an executive. They have reduced, they have increased the detection of at-risk event by 50%. That means they can find more fraud, 50% more fraud. And they have improved the model precision, or basically reduced the false positives. What do I mean by false positives? False positive is when you decline a legitimate transaction thinking that it is fraudulent. And that's the best part, is that along with cutting the fraud in half, they've also improved the accuracy of their model by 50%. So imagine what it can do for you if this can do the same thing for your organization. So come and have a conversation with us. We'll be happy to chat with you. I'm going to cover in database machine learning briefly, because we started a little bit late and I want to be conscious of time. In database machine learning is, remember we talked about feature generation, we took the fraud detection example. We can export it out to your machine learning system like your TensorFlow system, or your another type of open source Python based system that you're using for machine learning, or we can do machine learning inside the database. This is where TigerGraph is unique. No other vendor out there has an in database machine learning available as a part of a graph database. So that basically means we can keep on learning constantly. We can do fraud detection, we can do recommendation engines, we can do knowledge graphs, we can do all of that with in database machine learning and provide you with real time results as a part of it, much faster than taking the data out into another ML platform. So what do people use it for? They use it for mission critical workloads where the turnaround time is really important. So we can typically cut the time that you have to insights in half or more using an in database machine learning approach. Community detection is something that's very popular. I mentioned that we use that a lot in our customers for fraud. Louvain is a popular community detection algorithm that's used. And what you are essentially finding here is groups of people who are connected. And that's something that's used. Louvain community detection with TigerGraph is used at 7 out of top 10 banks for fraud detection and money laundering detection, for finding groups of accounts that appear to be involved in fraud and money laundering. We also use community detection for understanding customer communities that are interconnected, or user communities that are interconnected on the technology side, and we help people foster communities as well. Is an example of a customer that has 10 terabytes of data, detected fraud rings with TigerGraph with Louvain, and has realized in just 3 months they deployed in production. First year ROI was $50 million. Total lifetime impact was greater than $200 million from TigerGraph. What is the TigerGraph difference, right? I'm going to cover it briefly in 1 minute here. Real-time deep link analysis, the ability to go to this 10 hops or more in real time and find fraud, find money laundering, find recommendations, find customer information insights that they've buried before. That is possible only with our architecture. Like I said, I'm not going to cover it in detail here, but I want to mention briefly the advantages. Massive scale. We are the only database that has deployments live in terabytes. Our largest deployment is over 40 terabytes. We'll be deploying 100 terabytes in the coming year. And then now customers, we are ready for a petabyte scale. So customers are talking about loading up petabytes into TigerGraph next year. We provide in-database analytics and machine learning, and we provide it much faster than any existing system out there. And for people who don't want to write code, we have no-code pipelines available from where you can take the data directly from relational database. No need to write extraction workloads. No reason to do any analytics. No need to write queries. You can simply select business objects inside a UI. If you can use PowerPoint, you can use TigerGraph to create advanced analytics queries and machine learning features without writing a single piece of code. With that, I'll invite you to TigerGraph Cloud. It's free. There's no credit card required. Go to tigergraph.com/cloud and experience TigerGraph for yourself. There are starter kits available for every major use case that I talked about, for supply chain analysis, for fraud detection, for money laundering, for recommendation engine. They are all available, and in 5 minutes, you can experience the power of TigerGraph with just your email. Lastly, I mentioned that event at the beginning. Graph Plus AI Summit Fall happens in October. The website is really simple, graphAIsummit.com. Please join us there, either virtually, it's free registration for you, or in person in 2 places. October 5th, if you are in San Francisco, you can travel to San Francisco, or October 19th in New York. We are restricting the in-person through nomination because we want to make sure that people are vaccinated before they come to the event. That's a requirement for attending in person. Or you can join us virtually if your schedule doesn't permit or if you're not vaccinated. But links are located right here at Graph AI Summit for both free registration for virtual registration and in-person nomination for either October 5th San Francisco event or October 19th New York event. I wanted to leave you with just who presented at April event, which is the spring event. You can see the who's who of companies that presented at the April event. Brad Spires of JP Morgan Chase, Harry Powell from Jaguar Land Rover, Ippen Digital, Forbes, IBM, Accenture, Deloitte, Amazon. Google will be presenting at Graph Plus AI Fall. We have amazing speakers every time, so I will just request you to please join us for Graph Plus AI Summit. With that, I know I'm at the end of my time, running a little over, so I'll hand it back uh, to the moderator, back to the conference. Thank you.